All right, now for question 3 on the worksheet, this would really exemplify what happens when there's a square, okay, for the factor in the denominator. So can you tell the vertical asymptote right away? X equals to 1, okay. It should take you no more than 1 second to tell the vertical asymptote. What about the horizontal asymptote? Y is equal to? Not 3, not 0, 1. Why? Good question. Why? Because x minus 3, when x is so huge, would the minus 3 matter? Nope. So the numerator is just x. Oh, wait, hold on. It is 0. It is 0. I forgot to look at the square. And then the minus 1 wouldn't matter. So you have x squared. So x over x squared, it's 1 over x. And 1 over infinity is 0. For those who said 0, good job.
Isn't it x over x squared? So it would be 1/2.
X over x squared will be 1 over x. And then you think about x being infinity, which is, well, 1 over infinity, it's practically 0. All right, do we have any x-intercept? Yes, because when the fraction equals to 0, that means the numerator will equal to 0. So x is equal to 3. All right, now, what about the y-intercept? Three comma, I mean, was 3 comma 0? And then for the y-intercept, it's when x is equal to 0. So when you put x equal to 0, you have minus 3 over negative 1 squared, which is just 1. So 0 comma negative 3. Okay. Now, so this is the challenge right here. How would you draw the graph? Well, like I said yesterday, if you look at let's just look at the left-hand side of the vertical asymptote. Would you draw the graph above or below? It would have to be below because you got to cross the y-intercept, right? You got to cross the y-intercept at the predetermined location. Now, but because of the square right here, that means there will be no sign change. So around the vertical asymptote, the graph would head to the same direction. So that's what's going to happen. And now, again, an asymptote, it's a guideline that the graph would get closer and closer to. And the graph will cross the x-axis, and then it will come back down to lean closer to the horizontal asymptote. So that's why on day 1, I said you've got to understand the definitions of what an asymptote is. You can think about it as a guideline that the graph would just lean closer to it as it goes. And also, this would be a great example to show you that, can we cross the horizontal asymptote? Yes, we could. Yes, we could. Okay, yes, we could. You can ignore the whole because we will talk about the whole in just a moment. Now, over here, when we say f of negative 1, it simply means x is equal to negative 1. What's the y value? There'll be negative 1 minus 3 over negative 1 minus 1 squared. So the denominator would be just negative 2, and then you would square it in a moment. So you have, what is it called? Negative 4 over 4, which is negative 1. So if I draw my graph more perfectly, I should include a point right here. Now, what I did earlier, if you show that, that's fine too. But since we have the f of negative 1 being negative 1, I guess we can put an effort to make the graph to look a bit nicer. Question? Yes, the vertical asymptote. What is the definition of vertical asymptote? Yes. Hold on. Let me hold the question first. What's the definition of vertical asymptote? Okay, vertical asymptote is when the function is undefined. Okay, that must be the first word that comes to your mind when you think of vertical asymptote. And when will the fraction be undefined? It's when the denominator equal to 0. And when will the denominator equal to 0? When x equals to 1. So that's how we get the vertical asymptote here at x equals to 1. Okay, so got to understand the meaning. Don't just focus on how to define it. Understand the meaning, and then the action would come together. And yes, what's the question about horizontal asymptote? Because x would be what? No. When we talk about horizontal asymptote, x becomes what? Infinity. So if you do infinity minus 3, what is the result of infinity minus 3? Still infinity. Okay. Can you process that? What about infinity minus 1? Still infinity, right? So therefore, the numerator will be just x, and the denominator will be just x parentheses squared. So that's why we have x over x squared. And then we simplify that, 1 over x. And then you think about x being infinity. 1 over infinity is practically 0. So make sure you have the train of thoughts, okay, linked up together.